Okay. All right. Having said that, welcome to anybody who's just watching this recording. Um, going to talk about adding decimals, okay, because that's kind of the first concept for our quarters. We're going to be talking about adding decimals. So let me see if I can move this over a little bit. I don't want to shrink it too much. So the basic rule with adding decimals is that you got to line up the decimal point. Okay, so that's why I've got this rule right here. It says line up the decimals. Okay, so be sure and copy that down. We actually do a lot of adding with money. If I say $2.25, okay, plus another 25 cents, it's really 0.25. I would line up those decimals, and then I would bring down the decimal right here and try to make it look like they're lined up here. See how they're all lined up? That's the rule, okay? Make sure you always line up your decimals when you're adding numbers. And that way you'll get the right answer every time. So let me model it for you, and I won't necessarily even add it all up. I just want to model it for you. If you had an equation like 2.46, okay, so if I wrote this down, 2.46 plus 0.005, so I could write this 0.005. Notice I've got my decimals, and then 16, okay? Somebody might be asking, what do I do with 16? Where is the decimal? In any number, like the number 7, the decimal is assumed to be right here. If you had $2, because somebody said, I'm going to give you $2, we tend to write $2 like this, okay? And so the decimal is always assumed to be right after the whole number. So that being said, if I wrote 1, 6 down here, point, okay, I've got all my decimals lined up. And then I always advise my students, put the decimal down in the answer right away before you do anything, so you don't forget what to do with it. And then that way, when you go ahead to do the adding, you've already got it where it's supposed to be. But once again, you'll see all my decimals are lined up here. Then I just have to add, okay? And again, just to show you one more time here, in this next equation, 9.043, and the next one is 0.27, so just 0.27. And then I've got another whole number here, 15, so I would write 15 point, okay? That's a decimal point, and again, in my answer, put my decimal down there, and then just start adding. At that point, I can ignore I've got all my decimals lined up, so I don't have to do anything. And by the way, you don't have to draw this little thing around it, but that's how you add decimals. And it also happens to be exactly how you subtract decimals, just so you all know.
So, Tim,
Yeah, go ahead.
I can't see the bottom of that equation.
Wow.
So it's, yeah, I think it's because your screen isn't expanded, or it's not in full screen or something.
Let's try, let's see what happens if I do this, Jess. Is that better? That's about as good as it's going to get. Okay, so 9.043. I'm writing it over here on the screen. Can you see what's going on over here? So
yeah.
0.23, 0.27. I'll try to keep everything a little higher, just see if that helps. And then I've got 15, 15. Okay, so, and the decimal point is assumed to be right here. And then I'll put the decimal in the answer, and then I would just add things up. Okay, thanks for that feedback, though. All right, so that's the rule. When you're adding decimals, you line them up. Okay. All right, I'm going to move on to subtracting decimals, and there's a rule here, and that rule is the exact same rule. So if you were taking notes, you might write down subtracting decimals, same rule, or same as adding, or something. And then I only have an additional note here, just as kind of a warning, to always put the smaller number, okay, on the bottom when you're subtracting, okay, for the same reason that I don't do 7 minus 9 until I get into negative numbers, okay? I put an X through that, okay? And the reason why I'm mentioning this to you is because sometimes you'll have an equation like this. You'll have, 2.3 minus 1.9786 or whatever. Okay, so I've got this equation right here. Some people might get confused and go, oh, well, I'm going to put this long big number first and then put this other one underneath it. Actually, 2.3 is greater than 1.9. So the 2.3 needs to go on the top, okay? And that's going to lead us to another couple of questions, but let me model this first equation for you. So I've got 15.2 minus 0.184. So again, I would write 15.2 and 0.184. This is perfect. Okay, this is a good example of what I wanted to show you next. All right. I'm going to give you a couple seconds to copy this down. And I'll model for you like I just taught you. Hey, put all 3 decimals in there. Put the decimal in the answer. All right. In this particular example, the reason why I wanted you to take a look at it is because how do I subtract 4 from nothing up here? Okay. So in case you forgot or were wondering, fill in zeros. Okay. Just fill in some zeros here. Okay. And then I'm going to change color. Remember I said I like to use color just to kind of illustrate things. So in this case, what I would do is it's that rule of borrowing. So I've got to go all the way over till I got a number I can borrow from. I would cross out the 2 and make it a 1. I'm going to bring over my 1. I still need to borrow from it. So I'm going to cross out that 10 and make it a 9, which makes this a 10 when I bring over my 1. Okay. So I now have 10 minus 4 is 6. 9 minus 8 is 1. 1 minus 1 is 0. 0 from 5 gives me 5, and nothing from 1 is just 1. So there's my answer, 15.016. Okay. So that's a good example of what do I do if I don't have enough digits on top to borrow from. And again, the next example, 3.2 minus 2.68. I'm going to write it up here so it doesn't disappear on you guys. 3.2 minus 2. I'm being really careful to line up my decimals. 0.68. And again, I was careful to make sure I got the smaller number on the bottom. And I'm also careful to make sure I put in my decimal point into the answer. And again, this is another example where I've got, oh, how do I subtract 8 from nothing? I'm going to make it a 0. I'm going to cancel out my 2 and make it a 1. I'm going to carry over the 1. So now I've got 10 minus 8, which is 2. 6 cannot subtract from 1. So I'm going to borrow from the 3, make it a 2, bring over the 1. 6 from 11 is 5, right? 6, 7, 8, 9, 10. Yep, 5. Okay. And then I've got 2 from 2 is just 0. So I can put 0.52 or I could just 0.52. Same thing. Okay. So I hope that's kind of a nice little review of adding and subtracting decimals. The key is line them up. Make sure you have your smaller number on the bottom, especially when you get a story problem. Okay. Sometimes you'll read a sentence or two from a story problem and you're subtracting because it'll say find the difference or something like that. And then you might ask yourself, well, which one do I put on the top and which one do I put on the bottom? You're probably, especially in this course, you're looking at putting the larger number on top. Okay. All right, let me move to the next slide, talk to you guys a little bit about a couple of practice problems. Let's do this. I think we have time. Why don't you pick any one of these? No, let's have you pick the first one. Why don't you just do number 1 by yourself? I'll give you a minute and I'll turn off my recording while you're working on this. Okay. try to turn off my recording. Pause recording here. So I'm just going to model for you how I would have done the first one. 123 is the first number. And again, notice there's no decimal there, okay? So I'm going to just put the decimal right there, okay? And then it's 2.6, so I'm very careful. I'm 2.6. I'm lining up those 9.02. I'm going to go ahead and do that. Hold on a second. Let me see if I can let somebody in the room. That's interesting. Hang on a second. Wow, I'm having trouble doing that. How about if I stop the recording? Pause. So anyway, this first equation here, I've got the first one at the top of the screen here. I've got 2.6 and then I've got 9.04. So 9.04. You'll notice I was very careful to line up all those decimals. And again, for the fourth time, I was really careful to put it in my answer, and then I can just start adding at this point, okay? 5, 14, that makes that a 3, which makes this 134.64, okay? All right, so that's a little bit of review about adding and subtracting decimals. And once again, if you had an equation like this number 3 down here, okay, again, I won't do the whole thing for you for the sake of time here, but 0.932, and again, I would put this, and then I would start borrowing here, okay? That's how I would do that equation. So just so you know. All right, then you can start subtracting. All right, moving on to a little bit about, whoa, what happened there? Teacher went too fast, too far. Oh, story problem. Hey, that's always great. Now for this, don't feel like you have to copy down the story problem. I just want you to listen and think with me, okay? Just so you kind of think through this story problem with me together. Find the total, just by the way, the total weight of 3 cartons that weigh 4.2 kilograms, 2.37 kilograms, and 0.45 kilograms. All right, they're all kilograms. But what I want to model for you is this right here. This word total usually means adding. Occasionally it could mean multiplying, but usually it's one of those key words, okay? It's one of our keywords when it has to do with that are giving me a hint that, oh, that's a keyword for adding, for plus, okay? So in this particular equation, I would go like this. I would line up my decimals, 4.2, 2.37, and 0.45. And I would put my decimal in my answer, and then I would just add things up, okay? So that's kind of how I do that equation. Let's look at number 2. From a board that was 2 meters long, Colin cut off. Oh, cut off. Take a wild guess. What am I doing there? If I'm cutting away from something, I'm subtracting, okay? This is a key word for subtracting. And so that's, he cut off a piece 1.67 meters long. How long was the piece that was left? Now, here's a little clue in looking for keywords. Look for the last sentence that has the question mark when you're trying to figure out a story problem. Look for the sentence that has the question mark and look for the keywords in that sentence. That'll be the clue just about every time, okay? So the last sentence is how long was the piece that was left, and it's got this question mark here. So I'm circling this, okay, here, and it's got the word left. Left means to subtract. It's one of our, which we'll go over here, I think. I know we went over it really well in TS60, but it's one of our keywords for subtracting. So what I would do is go 2.00, because that's how much I started with. And then I'm subtracting 1. Oops, I'm sorry, Jess. I'm going to move this up at the top, okay? 2.00, 1.67, 1.67. And then I'm going to subtract, and I'll put the decimal here, and I'm going to start borrowing and kind of go like that. Okay, so that's how I would work this equation down here. Um, all right, a couple of story problems here. Now, let's see what I've got next here. I have nothing except for my next slideshow, okay? So I hope I'm not going too fast here, but I'm going to talk to you a little bit about multiplying and dividing decimals for the remaining half hour of class. And we might get out early, just so you know. Just so you know, there will be a few times occasionally when we'll get out early, and there will be some times where when we will be really rushed to pack it all into an hour. So for the sake of the recording, I'm going to stop my recording here. Zoom recording. So there's a rule there that hopefully you guys had enough time to copy down, and that is the multiply the numbers like normal. Then count how many numbers are to the right of the decimal place in both original numbers, and then place the decimal that many places to the left in your answer. Now, honestly, I'll be honest with you. That is how to do it, but it sounds like directions on how to put a garage door opener in a house. It's like, okay, what does all that actually mean? Okay. So that's where I come in. That's where I'm just going to show you. We're just going to do this together for a minute. Okay. So it says kind of this multiply the numbers like normal. So if I had 4.36, okay, 0.36 here times 2. Okay. All right. Great example here. And you'll notice I'm not worried about lining up the decimals. When I multiply and divide, I'm not lining up decimals, only when I'm adding and subtracting. Okay, so you want that to be really clear in your mind that you only line them up when you're adding and subtracting. So what I'm going to do is 2 times 6 is 12. We'll put the 2 here and the 1 here. 2 times 3 is 6 plus 1 is 7. And then 2 times 4 is 8. Okay, so what I just did there was I multiplied the numbers like normal. Okay, I'm going to draw a little arrow here. Okay, that's what I just did. I multiplied the numbers just like I would normally do in multiplication. Then it says to count how many numbers are to the right. Okay, so in the whole problem here, and I want to emphasize the word whole, the whole problem. Okay. Um, in the whole problem, okay, how many decimals are to the right of the decimal point? I mean, how many digits are to the right of the decimal point? There's 2. There's 3 and a 6. There's 2 digits, okay, to the right of the decimal point. So it says to place the decimal that many places to the left in your answer. So here's what you do. You start on the far right and you count 1, 2. And that, ladies and gentlemen, is where your decimal goes. Okay. So I'll give you a few seconds to copy that. And I'm going to shrink myself on the screen here. Again, the next problem, 9.92 times 9, I'm going to write it up here so I don't get into it disappearing on the screen. 0.92 times 9, I'm just going to do my math, 18. 9 times 9 is 81 plus 1 is, whoa, what happened to my pen here? I used to have this happen. 81 plus 1 would be 82. All right, that's what it should have looked like. There are 2 digits in the problem that are to the right of the decimal, so it would be 8.28. Sorry, guys, about how beautiful that looks. 8.28, okay? All right. Now, I want to look at, I'm not even going to do the math in number 3 and 4, but I want you to look over here and just follow me. Once I multiply like normal, and again, when you multiply, you're not lining up your decimals. You're just multiplying the numbers like normal, okay? I would multiply, but then in my answer, I'm going to count how many digits are to the right of the decimal. I've got 1, 2, 3, and 4. I've got 1 down here. So I would move my decimal point 1, 2, 3, 4 places in my answer, okay? In number 4 down here, in the original problem, there are 1, 2, 3 digits. So I would move my decimal point 3 digits to the left. Okay. So that is the rule for multiplying decimals. All right. I hope that's clear. You got your notes, and I hope I've given you enough time to copy all that down. And I'm going to talk a little bit for a few minutes about dividing some. we've got also something called front end rounding, which I want you to go ahead and copy this down here. Something called front end rounding. Okay, so let me show you what I mean by here. We've got, in my example one, I've got use front end rounding to estimate the answer to 2.84 times 0.72. Okay, so what that means is you round to the furthest number that's actually a number to the left, that place. Okay, so as long as it's not a zero. Okay, you're looking for the front number that's not a zero. So this 2 here in 2.84, that's the front of the number. Okay, so the way I always teach my students is underline the place you're rounding from. Underline it and look to the right. If the number to the right is 5 or more, you round up. In this case, it is, because 8 is 5 or more. So this becomes 3 times, now let's look over here. I'm going to front end round this 0.72. 0, I'm not rounding to 0. I got to find my front end actual number. Now, technically 0 is a number, but it can't be 0. Well, that's the rule. So I'm going to underline my place. I'm going to look to the right, and I'm going to see that that's not 5 or more. 2 is not 5 or more, so it stays the same. So really, I've got 3 times 0.7, okay? Because it doesn't go up because it's not 5 or more to the right. 3 times, well, I know that 3 times 7 is 21. In the original problem, how many numbers are to the right of the decimal? There's 1. So my decimal point goes right here. 2.1 is my answer, okay? So that's this concept called front rounding. Let me give you another example. If I had 35.601 and they said front end round that number, okay, here's what I would do. I would, if I model it for you again, I would underline the front number. I would look to the right and say, yep, that is 5 or more. It's 5. So this becomes 4. That's it. Everything else is just like nothing, okay? Actually, I did that wrong, didn't I? It would be, what did I do here? So the 5 would make the 3 go up to 4. It would be 40 would actually be my answer. Yeah, technically that would be the answer. Sorry about that. Because 3 rounds up to 4, but I've got a digit here, so it'd be 40. And everything else is just like zeros, okay? When you round something, everything else after the number you round up to becomes zeros. So, so that would be a 40. All right, let's jump into the next concept, which is a little bit of review of story problems. All right, stay with me. Don't feel like you have to copy this down, but I'm just going to talk you through this again. Jane earns $14.90 an hour of overtime. How much does she earn for 2.3 hours of overtime? Okay, so, all right, so she earns this much right here, okay, for an hour. And that's how much she makes if she's doing overtime. But if she does, that's for 1 hour, okay? I just want to kind of point this out here. This is for 1 hour, okay? That's how much she makes. How much would she make if she worked 2.3 hours, okay? So what I'm going to do in this problem is 14.90, which is how much she makes per 1 hour of overtime, and multiply it times it's just 2.3. And notice again, I'm not lining up my decimals, okay? I'm just multiplying like normal. And then I would do the math and I would move my decimal point 3 places, okay? 3 places in the answer. All right, number 2 here, I'll call this problem 1, and problem 2 here. 1 inch, you got 1, okay, 1 inch here. 1 inch is equal to 2.54 centimeters. A 12-inch ruler is how many centimeters long? Round your answer to the nearest tenth, okay? So I'm going to do the problem in a different color, and I'm going to do it up above here. So you've got 2.54 times 12. Okay. Now I want to point something out to you guys. Notice I put the 12 in this case underneath because I kept the longer digit number on the top. Okay, and that's almost sounds like a reverse of what I told you earlier about subtracting. But that'll help you, that'll make more sense because let me show you what would happen if you didn't do that. If you did 12, okay, times 2.54, that just doesn't make sense because we don't multiply like that. We multiply with the longer number on top, and then it makes a lot more sense to us, okay? All right. And then once you get your answer, in fact, I'm going to take a moment here and just finish the problem here, okay? 1 and 4 is, that's a 5. And then I've got 4. Sorry, I'm squeezing everything in here. 5 and 2. All right, when I add everything up, sorry, 8. I'm sorry, there's all squeezed in here. 4. So this is going to be an 8. This is going to be a 4. And we've got a 10, which means that's a 1, and that's, so it's 3, 0, 4, 8. Okay, that should be what it looks like. Okay. Now, in the whole original problem, I only have 2 digits to the right of the decimal. So that's where my decimal goes, right there. But the question asks you to round this to the nearest 10th place. See that? Notice how I underlined that, okay? I'm reminding myself as a student, oh yeah, do it to the 10th place. Here's what I would do. In my answer, which is 30.48, 4 is in the 10th place, okay? Because it goes 10th, hundreds, thousands, etc. There's no 1th place after the decimal. After 4 is an 8. 8 is 5 or more. So my final answer should be 30.5. Okay? That should be my final answer on that. So that's modeling for you, rounding to the 10th place. Okay?
Don't forget to add the centimeters.
Oh, yeah. That's right. Centimeters. Thank you. Thank you. That's correct. Because it is actually asking for, yeah, it's asking for how many centimeters is it? 30.5 centimeters, okay, as an answer. Okay. All right, moving on, which means, yeah, in the problem above, it would be expressed in hours, okay. How much, oh no, I'm sorry, it'd be expressed in money. It would be expressed in money because it's asking how much they're making. Okay, going on to dividing fractions. All right, we're going to spend a couple minutes here on dividing. So I'm going to pause and let you guys copy this, and then it looks like we will probably take the whole hour here tonight. So I'm recording. Okay. So let's look at this example right here. I've got 0.8 divided into 7.68. Okay. So what I've got to do, this number on the left is called the divisor. That's just what they call it, okay? It's just a little bit of math terms. And then the number on the right is called the dividend. And like, it sounds like divided into, okay? It actually sounds sort of like what it is. So that's the dividend, and this is the divisor, okay? That number. All right. The way you do your division is, when you're dividing decimals, you got to get the decimal out of the divisor by moving it one place to the right, okay? In this case, because it's one place to the right. So whatever you do on the left in the divisor, you got to do the exact same thing in your dividend. Move it one place and then stick it above here exactly where it goes. And then, so that was the 3 steps. That was step 1, first, second, and third there. Now you're just dividing 8 into 768, and you got your decimal where it needs to be. Okay. So that is the rule, is you're just going to move the decimal point. Let's look at another example here. So that's example 1 here. Okay. I kind of call this example 2 here. 007, besides being a James Bond movie. Okay. I got to get rid of the decimal here in the divisor. So I'm going to move it 1, 2, 3 places. That means I got to move it 3 places in my dividend, but I don't have 3 places. So my solution is I'm going to fill in with a 0. That's what you do. You fill in with zeros. Now I'm going to move it 1, 2, 3 places. And I'm going to do step 3, which is to put it above in the answer. And now I'm just dividing 7 into 5,320 is what I'm actually doing now, okay? So again, when you're dividing fractions, you got to get rid of it in the dividend. Let me see what I have on my next slide here. Let me show you another example. Sometimes you'll have something like this. A simpler example would be 7 into 4.9, okay? All right, in this case, there is no decimal in the divisor, okay? It's assumed to be right here, which means it's where it's supposed to be. So in this case, you would just put the decimal right above where it is in the dividend and just divide. And 7 goes into it 7 times, okay? Because when I multiply like this, I get zeros, yeah. So my answer would be 0.7, okay? So when you have a whole number here, you don't have to do anything. You just have to put the decimal above in the dividend where it is. Okay. Going on to, we're almost finished here. Rounding numbers to the nearest fixed place, 10th, hundredths, thousands. Okay. So at this point, so find the answer to 4.3 divided by 0.7 to the nearest 10th place. If they ask you to solve something to a place, you got to go to the next place in order to figure this out. So let me show you what I mean. So if I've got 4.3 divided by 0.7, so it's 0.7. I can make this nice and large here, divided into 4.3. Okay. Now I'm going to model for you again. Get rid of the decimal in the divisor, move it 1 place. Move it 1 place in the dividend then, and put it above here where it goes. Now I'm dividing 7 into 43. 7 doesn't go into 4, but it goes into 43 6 times, because 6 times 7 is 42. And I'm going to subtract. All right. Now, this is a good example of long division. I have to do this to the nearest 10th place, right? That's the place after the decimal. So I'm gonna ask, will 7 divide into 1? No. I'm gonna fill in zeros here, okay? I'm gonna bring down 1 0. You get to do that, okay? You get to fill in zeros. 7 goes into 10 1 time. Now I gotta keep going. I'm gonna show you why. 1 times 7 is 7. Subtract from 10, I get 3, okay? Will 7 go into 3? No. I'm going to bring down my 0. See my other 0 here that I'm bringing down here, okay? Bringing that down. 7 goes into 34 times. Now, I can stop right there, okay? And here's why. Because I'm supposed to solve this to the nearest 10th place. I'm going to choose a different color here so it shows up better. This 1 right here is in the 10th place. I found the next digit, which is not 5 or more. So my real answer is 6.1, okay? Because 1 stays the same because 4 is not 5 or more. So it's 6.1. That is a little trick that you're going to have to do when you get into, if they ask you to solve to the nearest place, you got to find the next number over to the right to see if it's 5 or more, okay? So that's just kind of reviewing that concept. And here's a division problem, okay? And again, don't worry about copying it. Just kind of listen here, okay? Mark drove a total of 1,247.5 miles in 5 days. What is the average number of miles he drove per day? I'm going to divide 5 into 1, 2, 4, 7.5. I'm going to put my decimal right here, and I'm going to do the division, and that will tell me the average number of miles. Okay, he drives a day. Okay. And the second problem here is there are 1.6 kilometers in a mile. How many miles are there in 3.36 kilometers? I'm going to divide 1.6, 36.8. I'm going to move my decimal one place. I'm going to move my decimal one place. I'm going to put it right there. I'm now dividing 16 into 368 essentially, okay? All right, that's everything. Let me do this. Let me turn off my recording. Stop recording.